Hi guys. Again, my name is Joseph Ejikoji. I hope your days are going well. Um, Today our topic of discussion will be the measures of variations, which under this topic we'll be discussing variance and standard deviation, and also range and coefficient of variation. But for today, we'll be focusing on only the range, variance, and standard deviation. So let us begin. Let me share my screen so you can see what I'm talking about. Here you go. Okay. So like I said before, the measures of the measures of variation, like the variance and standard deviation, are used to figure out or to determine how far away data values have strayed from the mean or from the center. They tell us how far away, have strayed, and I will explain more on this. There are four popular measures of variations. They are the range, variance, standard deviation, and the coefficient of variation. This lecture will be focusing on range, variance, and standard deviation. The range simply means to calculate this and understand what you are doing, you really need to know some background information about these parameters. Range simply means the difference between the maximum value and the minimum value. Okay. Now variance give us, tell us how the data distributes itself about the mean. Okay. So now the standard deviation simply means the square root of variance. That gives us the standard deviation. So they still give us the same how far the data value have strayed from the center or from the mean. Now we can use variance, variance and standard deviation, of course, to do a lot of things. Now, for example, we can use them as a means or for measuring deviation from a given standard. For example, a manufacturing company like Coca-Cola can use, the management in those companies can use the variance and standard deviation to establish standards against which performance will be measured, such as dollar amount of sales, number of hours worked. So they tell us how how far apart, or let me put it this way, we use the variance and standard deviation to compare the actual performance of sales or sales or hours of work to the standards that is set up by the company. How have the sales, for example, how are sales doing when you compare it to the standard or the target of the company? Are we getting more of that? Are we getting more of that? Stuff like that. Now, the coefficient of variation, we'll talk about that in a different lecture. Now, let us see how to calculate these statistics. For the range, simple formula, that is the simplest measure to calculate. The formula is simply the maximum data entry minus the minimum data entry. We want to say it in a simple way, means the largest value minus the smallest value in a data set. For example, look at what you have here. It said a corporation hired 10 graduates. The starting salary for each graduate are shown here. Find the range for the starting salaries. Okay, all these salaries are in thousands. That means this one is 41,000 per year, $38,000 per year, $39,000 per year, and so on. So in this case, the range becomes range. Excuse me, no mistake. Range become maximum value. In this case, for this particular question, the maximum value here is 47,000. 47 minus The minimum is 37 because it's the smallest number here. 37. Giving us a range of 10. Means $10,000. So you can see that the difference between starting salaries for graduates or for the 10 graduates is $10,000. That's the difference. So the highest paid graduates in this group have earned 10,000 more than the other ones. Okay, that's it. Very fun, very easy. Now, the one that give more challenge to calculate are the variance and standard deviation, and we will turn our attention to them now. And the formula is sample variance, where you use sample because most time we work with samples. We can't do the entire population except if we are doing a census. So for the sample variance, say the sum of x squared, where x represent the individual data values, minus sum of x squared over n. In this case, n represents number of items in the list or in the data set, divided by n minus 1. And like I said before, the standard deviation is just the square root of variance. So the answer you got from this one, you find the square root of that answer to get your standard deviation. So let's do it. Now, when you look at this formula, they look like monsters, but they are not. I tell my students that all the time. They may look like monsters, but they are actually easy to use, as I'm going to show you in a few minutes. Look at this example here. It says, the data below shows how long in months that an experimental paint lasts before fading. It's a compute the variance and standard deviation. So the first thing you do is to put them into a table of values like this one. So you see all these numbers here, right here, and they represent our x. Okay. Now we need to find the x squared because it is a part of the formula. Now to find our x, you put x just at the numbers. When you add them, you get 210, and I'm going to show you how to add them to get 210. That this calculator that is free online that I always tell my students about. So I'm going to show you where the calculator is located by opening a browser. Let's use this browser. Okay. Now, this calculator, I'm going to share my screen so you can see it. For this calculator, it's called Desmos. So you have desmos.com/scientific. Press enter to bring the calculator out. So now, we have the calculator now. You can see it in my screen. Okay. Now, let us add this. You can see, so to add all these numbers to get the 210. So we have I have it on my paper already. So I'm gonna look at it by adding it to show you how to get this. So we have these numbers, the Desmos calculator. So we have 35 plus 45 plus 30. Okay, plus 35 plus 40. Okay, plus 25. See 210. You can see right here, 210. And that is how we got this number here, this total here for this. And you can see this symbol means the Greek, it means sum of. So sum of x, I mean all of this give us 210. How do we get this column? You square each number here. That means 35 squared. That means 35 times 35 give us 1225. I can show you on the calculator. So we have it 35 squared. With the Desmos calculator, we have okay, clear this 35, and this is the square symbol right here. Square give us 1225. which we can now go to the work we have here and put it right here, 1225. So in a similar vein, we square 45 square give us this number, 30 square give us this one. So we square all of them and add them the same way I showed you in this most calculator. It will give us 7,600. 7,600, okay? And that is our sum of x squared equal to 7,600. Now we are ready to calculate the variance. So be careful when making this table, because if you make any mistake here, all your answers will be wrong. Okay. Sorry about that, but that has statistics. Now you plug this in. Our sum of x squared, you see right here already, 7,600. We put it in this part. Okay, just 1 minute. I'll show you something. Make sure you're seeing this. Oh, I think you're seeing it. So our sum of x squared, this is right here. You can see right here, and it's 7,600. You put it right here. Minus sum of x squared. This is sum of x right here. It's 210 squared. That means 210 squared over n. Our n is how many items we have? 1, 2, 3, 4, 5, 6. 6 items is 6. Divided by n minus 1, I mean 6 minus 1. So usually I tell my students, go one more step of work before you can now put them in the calculator. So following that, I have 600 here. 210 squared over 6. Let me show you how you can get this part in the calculator. I have I'm going to share 210 squared divided by 6. So I'm going to share my screen. I got okay, clear. 210 squared, okay, divided by 6. Sorry, by 6, yes, which gives us 7,350. 7,350. Okay, 7,350. So we can now go and put it in the formula here. Okay, we have 7,350 right here. Then 6 minus 1 is 5. So now this one you can get from the calculator. 7,600 minus 7,350 divided by 5. So 7,600 minus 7,350. So I put them in parentheses. 7,600 minus 7,350. I close the parentheses. Divided by 5 was 50. So that our variance is 50. Now I'm going to take you back to the paper and blow. Have it. Our variance is 50. I'm sure you enjoyed it. The variance is 50. Okay. So now next thing is to find the standard deviation. So the formula is that it is the square root of variance, which is the square root of 50. That'll give us 7.07. I'm going to show you on the screen. Square root of 50. You have clear this. The square root right here. Square root of 50 is 7.07. I mean, sir, that's 7.07. Okay, what is my right here? Okay, 7.07. Right here. So that's what is standard deviation. Now, I'm sure you enjoyed this my lecture, and thank you for listening. And I will see you here in my next lecture. Thank you, and you have a good day.